Yeah, okay, I guess we'll do that. All right, so I'm going to be talking about ecological succession. It'll probably jump back and forth between primary and secondary. I was trying to insert some videos just before I logged on. But basically, in a nutshell, succession, just like you would infer by the name of, well, by the word itself, that it is a progression of change in an environment. And it usually occurs after either a natural or man-made, I wouldn't say disaster is the wrong word to use, but basically when an ecosystem has been wiped out, either through some kind of natural disaster or human activity, it is the gradual replacement of life in that area. It's kind of life returning, I guess you could say, something like that. So you can have disturbances like fires, landslides, hurricanes, or floods trigger a sequence of changes in the composition of a community. The last thing, just to remind you, the last thing we were talking about before the break was patterns in communities, specifically species richness and species diversity, and the stability of a community. So the more diverse a community is, the more stable it is, because you have a lot more relationships within the food web. We did food web quite a while ago, but I'm assuming you guys all know what a food web is, showing the relatedness between species. So imagine, like, picture in your head a food web, and then imagine one of those strings being plucked. The more strings you have between species in a food web, the more stable it is. So if you have a food web with only a few relationships and one of those relationships is eliminated, it has a much bigger impact on the community. Hopefully that makes sense logically. So when you have any kind of disturbance, certain species are going to do well immediately afterwards. And these are generally called pioneer species. I'll talk about those a little bit later. And then these are going to slowly be replaced by other species as you start to rebuild the community. So over time, the composition of the community changes. And this whole process is just called succession. So it's the gradual sequential regrowth of a species in an area. We see, basically, when you go outside, you see succession happening all around you. Most likely, this is something called secondary succession. For example, when you have a parking lot that has been paved over with cement and then abandoned, a lot of times you see cracks in the sidewalk due to environmental changes, like a lot of heat followed by maybe some rain that makes small cracks that become bigger. Even sidewalks, you see weeds start to push up in the cracks. And this is an example of succession. So here I've got an empty parking lot, even abandoned buildings, and like that. Sorry, I'm trying to putting in, there we go. So this is a great example of succession, and this is what I would call secondary succession. So imagine before the sidewalk was put in, before the gravel was put in, when it was still natural, and then of course humans come and we lay down the cement. And whether we lay down the cement in blocks, which you see there's the seam between this cement block and this cement block, here you can see a crack that has formed. But life always finds a way to sneak through the cracks and crevices. I want to see if I can download. There was a really good program that I saw. I can't remember what it was called, but it was something about like what would happen if humans disappeared and like how long it would take nature to completely take over. So like this building, for example, would be completely covered in plants. And I think it was something as little as 10,000 years. Anyway, if I can find that and download it, maybe I'll share a link. I'll put it on my Google Drive. I'll share a link to it. Maybe you can watch that if you want to. But the bottom line is, obviously, everywhere you look around, you can see evidence of human activity, but you also see evidence of nature kind of finding a way to get through those cracks. So there's two types of succession that ecologists have been able to recognize. First, like I said, is called primary succession. This is development of a community where there was no life before. For example, whether it's bare rock, maybe it's on a sand dune, or after a volcanic eruption. And, oh, sorry. This is a video about Mount St. Helens. This is a mountain, I believe it's in Washington State, like around Seattle area. Anyway, this is a volcano that literally exploded. I believe 30% of the top of the volcano blew off. Anyway, it's a video that's going to show you the succession around Mount St. Helens. This exploded in 1980. And hopefully this works. There we go.
My name is Sean Healy. I study forest dynamics. I study changes in carbon, changes in forest structure when they are disturbed, that is burned or cut down. I also study recovery, which is what we see a lot of following the eruption of Mount St. Helens.
That's the eruption there.
I visited it for the first time 20 years after. It was like a moonscape. A lot of it was still like a moonscape. You know, pieces of pumice on the ground, no vegetation. It has been a place of extraordinary change over the last 40 years, from really beautiful old-growth forest to a moonscape, and then back again to a lot of unbroken sort of 20-year-old forests, pretty high canopy cover, a lot of trees there now. From the fringes of the blast zone, you definitely see patterns of revegetation. They start slowly with a little bit of greening, but by the time you get to the end of the time series, it looks pretty dark green. And you see the same thing on the ground. You see a, you know, maybe not a 40-year-old forest, but something that looks 30 years old. And in this part of the country, trees are pretty tall after 30 years. What we're looking at is Mount St. Helens in southwestern Washington in 1973. The snow cover is what you see as white there, right in the middle of the mountain. It's surrounded by some dark, deep reddish forests, which is basically how this MSS imagery sees older growth forest. To the east of it, we see a lot of very active timber harvest. All of those patches of blue are recent clear cuts. Just to the north of the mountain there, you see a very large clear cut. That one happens to be about 2 square miles, which is really, really large by today's standards. And then Spirit Lake, just to the northeast of the volcano, you will see that the shape of that lake will change radically after the volcano erupts. Well, in this image, I mean, if you remember that large clear cut that I pointed out, you can see that it's starting to go from that bluish cast to having more red, which indicates, you know, recovery following harvest. And 6 years has passed, so you would definitely expect that in a very productive forest like this one. And it has been joined by a lot more clear cuts in that area too. I have looked at a lot of Landsat scenes. This is the biggest change from one image to another that I can think of. Forests and everything else many miles to the north.
So this is after the eruption, get rid of that. And all of this gray area, that's all ash that was spit up by the volcano there. That was right after the eruption in 1980.
Were just incinerated. The blast and the heat and the ash really leveled a lot. It looks from this image like Spirit Lake just to the northeast of the volcano is not there, but it is there. It's covered in logs. And most of the water in that lake got splashed up 600 feet or more and sort of dragged all of the trees that were on that wall down. Over the 40 years since the eruption, you know, we do see that recovery happens first in the places that didn't have, you know, that huge blast of heat and were not covered with many, many meters of ash or mud. In '84, the first thematic mapper, Landsat, was launched. So that really changes our ability to display this kind of image in something closer to true color. So it's much more intuitive. Green means green.
Okay, I'm just going to fast forward because he's kind of boring. But basically, these are all from satellite images, and you can just see how, fast forward a bit, see how much it's changed. There's 89, and you can see from the satellite images how succession, here we go, the 2000s, see how much greener that is compared to earlier. So of course, the last areas that are going to be, I don't know, I went back to 89 again. The last areas to be filled in are going to be right around the caldera, which is the center of the volcano, because this was the most affected area by heat, and this will be the most buried in ash. So it'll be among one of the last places to experience succession. So that's primary succession. Secondary succession is when you have an established community that experiences some kind of disruption, and then a whole new community is going to grow after that. So a good example of secondary succession would be maybe a forest fire, or again, even a natural disaster. So you can have a volcanic eruption, which actually constitutes secondary succession, or if you're talking about the formation of islands, because islands are formed through volcanic eruptions, that would be a primary succession because life was never there beforehand. So he's going to show you some pictures, I think, from St. Helens again.
Hi, it's Mr. Anderson, and in this podcast, I'm going to talk about ecological succession. Succession is simply a series of events by which life comes back. And so what am I talking about? Well, look here, we've got a picture of a forest, but this is a year after there was a forest fire. And so you can see a lot of the charred, burnt trunks. And so basically, a photographer came here, and he came here once a year to the same place and took pictures. And so this would be year 1, this would be year 2, this would be year 3, year 4, and year 5. And so basically what you see is life coming back and changes taking place. And that is called succession. And it tends to occur at a predictable rate and using a number of predictable species. And so basically succession we could break into 2 different parts. The first one is called primary succession. Primary succession occurs when you have bare rock. In other words, when there's no soil left. And so if you look at this lava flow, basically the lava flowed down here. You could see they've kind of cut a footpath here. But basically life is starting to come back. Life can't grow out here for the most part because there's no soil there. We can't have plants that start to grow there. And so we have to have erosion, we have to have wind and rain, and eventually we have soil, and then we can start to have plants come back. Another example of primary succession is right here. This is a picture of Mount St. Helens the day before it exploded. After it exploded, it looked just like this. And so here in Montana, we had about that much ash everywhere. And that just came from the top of this mountain as it exploded. Well, this would be primary succession because there's no soil left. It's all gone. It's in Montana, not in Washington. And so basically life has to reestablish itself. And so this
So a really good, I like the way that he describes that, is primary succession is where there is no soil, and secondary succession is where you do have soil, but the life has been destroyed. That's a really good way to describe it, actually.
This is a picture of Mount St. Helens now, a few years ago. And so this is on this on this rim up here.
So I can tell you here that this is a much longer time after the original eruption because I see trees here. Trees are going to be among the last species that are going to appear in an area after succession. So I just wanted to show you those pictures. So any new habitat is an invitation to any species that are adapted to be good pioneers. So again, the word pioneer means to be the first. And so I know it's ironic, but like when we look at American history, when you study American history, like when I was in the States and learning it, they talked about the quote unquote pioneers, the white people that basically came from the East Coast, that came from Europe and settled in the East Coast and started making their way through the West. And they called them pioneers, which is a complete mislabel because they weren't the first ones. Obviously, Native Americans were already living on the land. But again, that's a really good example of how history can be completely rewritten depending on who's doing the writing. So it's important to get different perspectives on different moments in history, I guess you could say. So pioneer species are going to be small. They're going to be fast growing, fast reproducing. They're going to probably be like moss, lichen, a lot of bacteria, things like that. They're going to be adapted for invading and occupying a disturbed habitat. Especially with primary succession, you're definitely going to see species like moss and lichen, things that are adapted to be able to living on straight, bare rock. So here is an example of a pioneer species. Of course, this one, the soil is already established. So this would be secondary succession. I can see plants back there. This is definitely primary succession because you've got the moss, which is growing straight from the rock. It does look like there's a bit of lichen on the rock as well. And this is a really good example of the steps that you see in succession. So you would start with something like this. When the moss or the lichen, they break down the minerals in the rock also through erosion. And when they die, you have new generations that build on that. And slowly this starts to build the first layers of soil. Once you have the first layers of soil, then you see small plants like this coming in. And then again, we go to this picture here where you see the smaller, bushier plants in the foreground. In the background, that is when you have your trees that come in and become established. So primary succession is usually a lot slower because, again, there's no soil, and you have to use these pioneer species to build up the minerals and create soil. A really good example of primary succession is in something called the Canadian Shield. Up in Canada, the glaciers retreated from Eastern Canada about 12,000 years ago. If you don't know anything about glaciers, as glaciers retreat, they literally scrape everything as they go. So basically you just leave large deserted rocks behind. So all the soil is scraped away. You can see that here. This is as the glacier retreats. You can actually see the path of retreat from the glacier, leaving this part alone. So the glacier was just here in this valley. As it retreats this way, it scrapes everything away from the rock. So that's called the Canadian Shield. Obviously, plants and animals can't live there because there's just bare rock. But again, you have weathering and erosion, the constant freezing and thawing over the years, along with precipitation like rain, sleet, snow, things like that. It starts to break up the rock. You have lichen. Lichen is a mutualistic relationship between fungus and algae. This can live on bare rock. Here you can see the lichen here. The lichen produces acid, and that is going to digest, or not, maybe not digest is the wrong word. It's going to break down and break down the minerals in the rock, and then that will wash away. Excuse me. Eventually, dead organic matter from lichen, along with the minerals that are being eroded and eaten away by the acid, it starts to form your first layers of soil. Once you form your first layers of soil, then you can have some small grass-like plants start to grow. Now today, this is what the Canadian Shield looks like. That same area, which you could see all of the rock that was exposed, now today looks like this.
Primary succession. Let's see how primary succession occurs. Some species of lichens and mosses can live on bare rock. They release acids that can break rocks down into smaller particles. In this way, lichens and mosses start the process of making soil. They are usually the first species to inhabit an area. For this reason, they are called the pioneer species. As soil builds up, other plants can grow, grasses and small flowering plants, then shrubs, and finally trees. Each plant species attracts certain animals, such as insects and birds. These animals attract other animals. As new species arrive, they continue to change the physical conditions of the habitat. This paves the way for even more new species and causes others to disappear. This continuing change in species is succession.
Now, one of the important things that the guy mentioned, I think his name was Mr. Anderson, that he said it's a very predictable process, right? We know how long succession can take, and we know what kind of plants to expect during the process of succession. So if we can identify the stage of succession, then we know what kind of things we're going to expect in a specific amount of time. So secondary is succession, where you had an existing community that's cleared by a disturbance. Again, the soil is left undamaged. And I think what Mr. Anderson said is a great way to distinguish between primary and secondary succession. Primary succession, there is no soil. Secondary succession, the soil is left undamaged. It could be that you have like, we had, gosh, what year was that? Was that 2020? I think in the beginning of 2020, or was the beginning of last year, when the Australian wildfires, when like literally half of Australia was on fire, I think we lost 1 billion animals. That would be secondary succession. Secondary succession is not going to take as long as primary succession, because of course you already have the soil established there. So you pretty much can skip the moss/lichen stage and you go straight to the grasses and shrubs that come in, but trees are always the last species to come in. So this is a really great graphic on, I guess, the progression of plants that grow. So you can see there's small little individual plants here, followed by more bushy plants. Here you get more bushes, and then finally trees are the last thing to grow. The traditional description of succession is that the community goes through a predictable series of stages until it reaches a stable endpoint, and that's called the climax community. This is when you have a fully established, stable ecosystem. Now, at each stage of succession, you're going to have different categories of life that's there. For example, in the beginning, when you have moss and lichen, that's going to attract certain types of animals and other plants. As you go through the progression here, you can see what kind of animals you can attract by having different plants there. So at this stage, you're not going to have a lot of birds. Why? Because birds tend to build nests in trees. So you're not going to have a lot of birds. You might have more like rabbit and fox type animals that kind of hide in bushes, maybe some lizards, things like that. So it's really important that we study succession, because we can study, and a great example is that wildfire in Australia. I think that was the beginning of last year. I don't know, all the years, the last 2 years are kind of combined together with one disaster after another, but pretty sure that was beginning of last year. So it's important that we study that, because the more we have the climate changing, the more disturbances we have more floodings, we have more wildfires. And so it's important that we understand how new communities are going to build up. So each stage in succession is going to pave the road for the next. You would never look at lichen covered rocks and say, "Ooh, that's a climax community." No, you would say that's the beginning of a new period of succession. A climax community has to be constant for a long period of time, but it's not always that simple. Some climax communities are still not stable and continue to change. And this is more and more true as we keep seeing more and more examples of how climate change is affecting our planet. We have more disturbances more often in more areas of the planet, which is why it's so important that we try to do everything we can to do our part to try to slow that process down. So the actual path of succession can depend on several things. One, the identity of the species, the order that they arrive. Of course, climate is a big thing. You're not going to look at succession in Thailand the same you're going to look at succession in Australia versus Canada, because obviously the climate is different. But the types of species available to replace A community is different. So of course, even though it's a predictable set of steps, it's going to be, what do you call that? Characteristic of the area that you're in. So a single successional pathway ending in a climax community, too simple. Of course, you're going to have roadblocks along the way. You might have minor disturbances as you do so. Okay.